Okay, let's try to do some past paper questions now. This question is actually from CE module, May 2010, question 6. So for the first part, they want us to sketch the graph with the equation f of x plus 3. Okay, so all we have to know is to move the whole curve to the left by 3 units. So it would look something like this for the part A here. So this one will be y, and this one will be x. So how is it gonna work? The point A here will be -2 and 3. If I move the whole thing to the left by 3 units, x coordinate -3 will be -3. So it will be turning to -5 and 3. And also for the point B, if this one is 3 and -5, and I have to move the whole thing to the left by 3 units, so 3 minus 3 would be 0. This one here would be 0 and -5. And also here, this one originally is 0 and 0. Now they will have to become -3 and 0. The curve should look something like this. This one here would be 0 and -5. And here would be -3 and 0. And the point for A would be, and this one is B, would be -5 and 3. Okay, so for the part B, they want us to sketch the graph y equals to 2 times f of x. Okay, so I'm gonna rub all this thing first. I'm gonna draw the graph here. And this one will be y, and this one will be x. So all we know that is, because this one is 2 times the f of x, so all we have to do is to times all the y coordinates by 2. So if the y coordinate times 2, then the point would be -2. Not gonna touch the x coordinate. 3 times 2 would be 6. And this one here, 0 and 0, would be 0 times 2 would be also 0. So 0 and 0. But for this point would be 3, and y coordinate -5 times 2 would be -10. So the curve should look something like this. And yeah, basically make the graph looks taller, like basically stretch it vertically. The point would be -2 and 6. This would be A, and this one is originally B, 3 and -10. This one would stay the same, 0 and 0. Okay, for the part C, they want us to write down the value of A when the graph of y equals to f of x plus A has the minimum at 3 and 0, where A is a constant. Okay, so they want the graph to have the minimum point of 3 and 0. So this one here would be the minimum, and this one here would be the maximum. Basically, they want this point to be here, and here should be 3 and 0. So how are we gonna convert this point up to here? Easy, just plus 5, plus the whole thing by 5. So A should be 5. Y equals to f of x plus 5. Therefore, x will be equals to 5. Okay, let's do the marking now. For the part A, it carries 3 marks. So I think 1 mark is for the method, 1 mark is for the correct point B, and another mark is for the correct point C. And for the part B, I guess 1 mark is for the method, 1 mark is for the correct point B, and 1 mark is for the correct point C. And for the part C, there's only 1 mark. So basically, if you get the answer right, you will get the 1 mark. If you don't, you will probably lose the 1 mark. So 1 mark there. Okay, let's move on to question 2. This question here is actually from CE module, May 2013, question 8. Okay, so for part A, they want us to sketch the curve C with the equation y equals to f of x plus 2. So just move the whole curve to the right by 2 units. So it will look something like this. This one is y, and this one is x. The point here originally is -3 and 0, right? Just subtract 2 from the x coordinate. So basically, after moving the curve, the point would be -5 and 0. And same as here, the original point is 1 and 0, right? But after moving it, subtract 2 from 1 would be -1 and 0. So the curve should look something like this. Yep, would look something like this. And this one will be -5, 0, and this one will be -1. Okay, so for the part B, they want us to write down the equation of the curve. So all we have to do is to substitute x plus 2 into the x value. So it will be x plus 2 brackets plus 3 close the back brackets square and x plus 2 minus 1. And the next step would be x plus 5 square x plus 1. And I think this is already the equation for the curve C. So for the part C, they want us to use the answer part B to find the coordinate of the point where the curve C meets the y-axis. Okay, so basically they want us to find the solution of this point. From there, when x equals to 0, if we substitute 0 into this equation here, 0 plus 5 square times 0 plus 1 would be equals to y. From there, y would be equals to 25 times 1, which will be 25. Therefore, the coordinate will be 0 and 25. Okay, so for the marking, for the first part it carries 3 marks, second part it carries 1 mark, and the part C it carries 2 marks. So for the first one here, 1 mark is for the correct horizontal translation, 1 mark is for the correct point of translation, and another mark is for this point getting correct. Okay, so for the part B, it basically just 1 mark. So if you get this one right, you get this right. So basically 1 mark here. And for the part C, 1 mark is for the working and 1 mark is getting the final correct answer. Okay, let's carry on with question 3 in the past paper. This question is actually from C1 module, June 2009, question 10. Okay, so first thing for the part A, they want us to factorize completely x cubed minus 6x squared plus 9x. So first thing first we have to do is to take out the x from this equation here. So it will be, okay, I'm just gonna copy the equation down first, and the next step will be x times x squared minus 6x plus 9. From there, x would be x minus 3 squared. But how can you actually know that 3 would be the critical value for this equation here? You can actually use the calculator to get the critical value first, and then know that there's only one x minus 3. Let's say if I use the calculator, let's say if you are using the calculator, you can press alpha, load 5 and 3, and just put all A, B, and C. So first one will be 1, -6, and 9. And press the equal button. The critical value of x would be 3, and that's it. So when x would be only equals to 3, then x minus 3 would be equals to 0. So this one here would be one of the factors in this equation. But there's only one critical value, so we will have to square it. And for the part B, they want us to sketch the curve x cubed minus 6x squared plus 9x. Okay, so for the part B here, actually here's also part B. First thing first we have to do is to find the critical value of x first. Okay, so x would be equals to either 0 or 3. That's it. So let's draw a graph now. This one will be y, and this one will be x. Okay, so all we know is this point here will be the critical value, and 3 here will be the critical value. So now we have to do is to know which area would be positive or negative. So if I just copy the x-axis downwards, this one will be 0 and 3. Now we have to substitute any value that is between 0 and 3, let's say 1. If we substitute 1 into this equation here, we'll get 4. So 4 would be positive. And if we put any number that is greater than 3, let's say if we put 5, okay? 5 cubed minus 6 times 5 squared plus 9 times 5 would be 20. And 20 would be positive value, so I will just put positive here. So we all know that the range between 0, 3, and greater than 3 would be positive, right? Positive area, positive area. What if we put any number that is smaller than 0? Let's say -1, okay? If we put -1 in here, -1's cube will be -1 minus 6 times -1 square plus 9 times -1 would be -16, and -16 would be negative sign here. So the curve should look something like this. It should look something like this. And this one will be 0, and this one will be 3, 0. Okay, for the part C, use the answer to the part B, or otherwise, sketch on a separate diagram the curve with equation x minus 2. Okay, so basically it is y equals to f of x minus 2. So what we're gonna do, we have to move the whole curve to the right by 2 units. So it should look something like this. This one is y, and this one is x. Okay, so if I move this point to the right by 2 units, this would be what? 5, 0, right? And if I move this point here to the right with 2 units, would be 2 and 0. Okay, I'm gonna just write it down here, 2, 0, and 5, 0. And that would be the answer for part A, B, and C. So for the part A, it carries 3 marks, part B, 4 marks, and part C, 2 marks. 1 mark is for the method, 1 mark is for the working, and 1 mark is for the final. For the part B, 1 mark is for the correct shape, 1 mark I guess is for working, 1 mark is for the correct point, and another mark is for another point. And for the part C, it says 2 marks, so I guess 1 mark is for moving the whole curve horizontally, and another mark is for correct points or correct coordinate. Okay, let's do one more question here and then we're done with this topic. For the part A, this question here is actually from C1, May 2014, question 4. And for the part A, they want us to state the x coordinate of the point A. So basically this curve is crossing the x-axis here. So all we have to do is to substitute y equals to 0 into this equation here. 0 equals to 1 over x plus 1 would be 1 over x equals to -1, and x would be -1. And for the part B, the curve D has equation of y equals to x squared times brackets x minus 2, close the brackets. So they want us to sketch a graph on this copy here. Okay, so actually part B shouldn't be written here. B should be written here. Okay, so in this copy here, we have to sketch this equation here. So all we know is the critical value of x when y is equals to 0 is 0 and 2. So it will be here or here. Now we have to know which range would be positive and which area would be negative. So if we substitute 1 into this range, then we will get the answer of 1 square would be 1. 1 minus 2 would be -1. So this one here would be negative area. But if we put any number that is greater than 2, let's say 5, okay? If we put 5 into this equation here, 5 squared would be 25. 25 times 5 minus 2 would be 3, would be 75. So this one here will be positive. And if we put any number that is less than 0, let's say -1. If we put -1 into this equation, -1 squared would be 1 times -1 minus 2 would be -3. So -3 times 1 will be negative value. So the curve should look something like this. Yep, should look something like this. Negative, negative, and positive. And for the part C, they want us to use this sketch to find the number, okay, not the value of x or something, just the number of the real solution to the equation of these two, 1 and 2 intersection. So we can obviously see there are two very clear intersections, which is 1 and 2. So the answer would be 2. Or we can write it in a complete sentence. The number of real solutions would be 2. So for part A, if you get this right, then you will get the 1 mark. For part B, 1 mark is for the shape, curve shape. 1 mark is for the correct coordinate, and another one is for crossing the points. And for the part C, that's 1 mark. So if you get the answer for 2, then you get that 1 mark.